We're looking at scientific notation today, and something that I want you to remember for this that might help you out is that you always want to only have one number to the left of the decimal, okay? So only one number to the left of the decimal. So that should help you out a little bit when trying to put things into scientific notation, okay? So there's two situations that you could have. You could have it when the exponent is positive, and you can have it when the exponent is negative. And basically, it's still the same. You're still going to only have one number to the left of the decimal, but what makes them different is that when an exponent is going to end up being positive when you put something in scientific notation, the key thing is, remember, you're moving the decimal to the left. When it's negative, oops, it's the wrong left. You're moving this left. Here you go. Okay, so you're moving the decimal to the left. When it's negative, you're going to be moving the decimal to the right. Okay, and so what you do is you start at the decimal that's given. Sometimes you might see it there right away, sometimes you may not, but from there you're going to either move the decimal to the left or to the right. Basically, you're moving it in the direction that is heading towards some regular numbers. So I use this word regular right here. Regular basically is my way of saying that it's not zero. So any number that's not zero, you want to move them towards those numbers that are not zero. Okay, so if you're moving them, if for you to move to numbers that are not zero, if you have to move to the left, the exponent is probably going to be positive. If you have to move to the right to get to numbers that are not zero, then the exponent is probably going to be negative. Okay, so here we go. Here's how this is going to work. So let's go ahead and look at number 1 here. And let's see. So I have this long number, and the purpose of scientific notation is basically to condense these long numbers and make them into shorthand, I guess. Okay, so looking at this, you see a bunch of commas, and there should be a comma right here too, actually. So you see a bunch of commas, but you don't identify a decimal. What that usually means is that the decimal hasn't been written because there was no purpose to writing it at this point. But when that happens and you don't see a decimal, usually the decimal is all the way at the end, okay? So if you look at the problem, you don't see a decimal, draw one all the way at the end. And so now what's going to happen is, starting at this decimal that you drew in, again, you drew it in because you didn't see one from the original problem. What you want to do is, again, remember, you're moving towards the non-zero numbers. So the non-zero numbers is going to the left, okay? So what did I tell you? When you move to the left, how is the exponent going to be? Is the exponent going to end up being positive, or is it going to end up being negative? So when you move to the left, you see the word left right here. When you move to the left, you're going to end up getting a positive. Okay, so here we go. Let's count, and as we move the decimal, we're going to count how many places we moved it. Remember, we only want one number to the left of the decimal, so the stopping place has to be right here at the 6, okay? That has to be the stopping place right here, because if we only want one number to the left of the decimal, if we kept going, there'd be no number there, okay? So let's count. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got to the arrow, which means stop. Okay, so I went 13 places. And so this is how you do. You just write a little 13 here on the next line, a really tiny one. Okay, and what you're going to do is, that 13 is going to stay positive. That's your exponent. And the way you write this is, once you've written the 13, you put a base 10, which is the big number. So 10 to the 13, we do not make this 13 negative, because since we move to the left, the exponent is going to be positive. You're going to put a little x, because that x represents times. And now what you do is you take these numbers in the front, all the numbers that are not zero, so the 6, 4, 8, and 3 in this case, and you write them here. And now you place the decimal where you stopped. So the decimal was in between the 6 and the 4, so it goes right there. So final answer for this, for scientific notation, is 6.483 times 10 to the 13th. So that's taking a number and then putting it in scientific notation. So looking at number 2, we see a bunch of commas, but we do not see that decimal, so that probably means that we have to draw it in ourselves. So remember, when we have to draw it in ourselves, just automatically put it here at the end. Yeah, these are all commas. I apologize if you couldn't tell, but yeah, those are all commas. So we draw our decimal in at the end. Which direction do I have to go to get to the non-zero numbers? Am I going to the left or am I going to the right? We're going to the left, okay, that's where all the non-zero numbers are, so it's over here, the 5, 8, 1, and 2. Remember, the rule is you have to have one number to the left of the to the left of the decimal, so my stopping place would be right here, okay? It'd be right here in between the 5 and the 8, so that would leave me with the 5 on the left side of the decimal, the only number there. Okay, so let's start counting how many spaces we have to go to get to that stopping point. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we go 10 places. So because we move to the left, the little 10 here for the exponent stays positive. Remember that the base of that is always 10, so it's 10 to the 10th times. Let's write all of our non-zero numbers, our regular numbers. So those would be a 5, 8, 1, and 2. And then the decimal goes right in between here, between the 5 and the 8. So that leaves me one number to the left of the decimal. So we have 5.812 times 10 to the 10th. Okay? And we box it and we're done. Now let's go on to number 3. Number 3, looking here, do we see any decimals right from the get-go? We see it right here, right? There's decimal right here. So that means that this is not going to be one we have to draw in. Now, since we found the decimal, which direction am I going to go to the non-zero numbers? For me to do that, I have to go to the right this time, okay? So remember, I can only have one number to the right of the to the left of the decimal, one regular number to the left of the decimal. So the stopping place would have to be here. So even though I have all of these zeros that's going to end up being to the left of the decimal, I have 1, 8. This is where it would have to go, because if I put the decimal here next to the 9, then I have two numbers, two regular non-zero numbers that are going to be to the left of the decimal. So the stopping place has to be this 8 here. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here's my stopping place there. So I went 10 to the right, so I'm going to put a 10 for the exponent. Because I moved to the right, remember the exponent becomes negative. My base is still 10, my big number is still 10, times my two regular numbers is 8 and 9. And so the decimal goes right here in between them, and that leaves me with one number to the left of the decimal, this 8. So again, if I put the, let's say I erase that and I put the decimal here, for some reason you might think that the decimal might go after the 9. That doesn't satisfy the requirement, right? Because now I have two numbers to the left of the decimal and that didn't work out. So it has to go right here in between the 8 and the 9. Okay. And there's my final answer for this. Okay. Number 4, there's this random dot here that's not a decimal, it's just a stray dot there. But let's look at number 4. Do we see a decimal right from the get-go? We see it right here. The non-zero numbers are going to the right, so I know my exponent is going to be negative. If I need one number to the left of the decimal, my stopping place would have to be right here in between the 7 and the 2. So let's count. We start from the decimal. 1, 2, 3, 4, 5, 6, 7 is the stopping place. So I draw a 7 in the exponent. Because I moved to the right, that 7 is negative. The base is 10 times all my non-zero numbers, 7 and 2, and then we establish that the decimal goes in between the 7 and the 2. So there is my answer in scientific notation, 7.2 times 10 to the negative 7. Now looking at these, we just put some regular numbers into scientific notation. Let's see what we notice here, okay? So I'm going to focus specifically on example 2 and example 3. So let's focus specifically on these two. Now looking at example 2 right here, looking at the original problem, you guys notice that this is the one where we drew the decimal. So remember, the decimal is right here where I'm overemphasizing that orange dot right there. So the decimal started there. And what do you notice about that? So when the decimal starts on the right side, and we have to move towards the left, we notice that the exponent is positive, right? And we notice that our non-zero numbers are on the left side, okay? So our non-zero numbers end up on the left side. And so this 10 right here is the number of places we had to go. So it's including these three numbers right here, right? The 8, 1, 2. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those three numbers that are to the right of the decimal are counted in this number in the exponent. So a pattern that we can notice is that when the exponent is positive, that means that the non-zero numbers were on the left side. Okay, so that's why there's an L right here. And that not to forget that anything that's to the right of the decimal counts in this numbering of the exponent, number of places for the exponent. If we jump down here for number 3, we had to go to the right, and so when the exponent is negative, okay, right here, when the exponent is negative, that tells me that all my non-zero numbers this time are going to be on the right side, okay, and that counts all of the numbers that are in between the original decimal and the new one. So we have the new one goes right here where I'm drawing right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So everything from decimals in between the two decimals, all those numbers count, even this one non-zero number. So why I'm bringing this up is because what we're going to do is we are going to, let me get this to fit in the screen here. We are going to be working backwards. So this time they give us something in scientific notation, and what we're going to have to do is get it back to its original number. Okay, so let's start here. Let's start at the exponent because that's what's going to tell us a lot. So this exponent is positive, right? So what that tells me is that, remember, when it's positive, that means that all of these numbers, all these non-zero numbers, are going to end up being on the left side in my final answer. So we have 6, 4, and 7. Remember, when we first start the problem, the decimal is not there yet, not when it's positive. We have to draw it in ourselves. So the decimal starts off right here, right in the problem, when it's in scientific notation. And so we know that between the decimal that we draw in and the actual original number decimal, there has to be 9 spots, just like what that exponent says. So including these two numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 9 slots, right? So how many zeros am I going to have to fill in here? I'm going to have to fill in 7 for this to make sense. Okay? So if you don't believe me, say that we started with this big long number. I don't know why that turned into blue here. Okay, let's say we started with that blue number right there. Okay, so, or with this long number, the decimal would have ended up right here because we don't see it from the get-go, and our goal is we're trying to get it in between the 6 and the 4 so that we have only one number to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that matches the exponent in the original problem, and then the 6 would be first with the decimal, and then 4, 7. So that's just what I just did right now, is just if you needed to check your answer. But what is the final answer in this? The final answer in this would be you giving me the original problem again. So you can put the decimal if you want to at the end. You don't have to when you're working backwards like this, okay? Let's go ahead and try this number 6. So the exponent is positive, which tells me that the non-zero numbers are going to be on the left side again. So I have the 4, the 9, and the 5. So to the right of the decimal, all those numbers count in this count of 8. So I have 1, 2, and I'm going to need to fill in up to 8. So here's 3, 4, 5, 6, 7, 8. So I'm going to fill these all in with zeros. And let's just double check and make sure that this is correct. So if this was our original problem, this one I just wrote, I would draw on the decimal right here at the end, and I go 1, 2, 3, 4, 5, 6, 7, 8. This would be my stopping place, right? Because that's where the where one number would lie to the left of the decimal, and that would give me positive 8 because I moved to the left, and then the 4.95 as the non-zero number decimal thing. So that's correct, okay? So this is the correct thing. Again, if you're not sure what the answer is for this, we're working backwards, so this would be the answer, starting from the big long number. So they're giving us the answer, or they're giving us the problem in scientific notation, and they want us to work backwards now. Okay, here we go. Oops. So number 7, what we're going to be doing is same thing, but this time my exponent is negative. So when it's negative, remember these non-zero numbers, they end up on the right side. And so the only number that gets included when that happens, when you're putting it on the right side, the only number that gets included in your exponent number is just this first one. Okay, and so that's 1, and we need to go to 7. So there's 1, 2, 3, 4, 5, 6, 7, and then remember the dot comes here, and then we put it 0 point, and all that happens here is we just fill this all in with zeros. Okay, so 1, 2, 3, 4, 5, 6, 7. If you want, you can check your answer. So if we were working to check our answer, we know that the decimal would have to fall right here, and so we go 1, 2, 3, 4, 5, 6, 7, and that matches up. That would match up with our problem with the scientific notation they gave us, and we did that right. Okay, so final answer for this would be this guy. So hopefully this is making a little sense to you. I hope. It's not meant to be tricky. And so if you want, let's do one last one here, and why don't you try this one by yourself, and I'll do the work, and you can check to see how you did. Okay?